we introduced the concept of electric field by understanding the distribution of electric charge at rest, which creates an electric field E in the surrounding space. And then this electric field exerts a force F is equal to QE on any other charge Q that is present in the field. Similarly, we can describe magnetic interactions. A moving charge or a current creates a magnetic field in the surrounding space in addition to its this electric field, and the magnetic field exerts a force F on any other moving charge or current that is present in the field. So there are four main characteristics of the magnetic force on a moving charge. First, its magnitude is proportional to the magnitude of the charge. Proportional to the magnitude of the charge. Like if a 1 microcoulomb charge and a 2 microcoulomb charge move through a given magnetic field with the same velocity, experiments show that the force on the 2 microcoulomb charge is twice as great as the force on 1 microcoulomb charge. Now the second point is the magnitude of the force is also proportional to the magnitude or strength of the field. It means if we double the magnitude of the field, for example by using two identical bar magnets instead of one, without changing the charge or its velocity, the force doubles. Now the third characteristic is that the magnetic force depends on the velocity of the particle. Here it is different from the electric field force, which is same whether the charge is moving or not. Here a charged particle at rest experiences no magnetic force in the case of magnetic interactions, magnetic forces. And now the fourth point is, by experiment we find that the magnetic force does not have the same direction as the magnetic field, but instead it is always perpendicular to both magnetic field and the velocity. The magnitude of the force is proportional to the component of velocity perpendicular to the field, and when that component is 0, it means that V and B are parallel or anti-parallel, the force is 0. Here in this, a charged particle moving parallel to a magnetic field experiences 0 magnetic force. The direction of force is always perpendicular to the plane containing velocity, and B, its magnitude is given by the relation F and sine phi. So in this case, a charged particle moving at an angle phi to a magnetic field experiences a magnetic force with magnitude F is equal to QV perpendicular into B. And in this case, okay, so if a charge moving perpendicular to a magnetic field experiences a maximal magnetic force with magnitude then when they are perpendicular to each other, max is equal to QV when they are perpendicular. So this description actually does not specify the direction of force completely. This one, there are always two directions opposite to each other that are both perpendicular to the plane of V and B.